Hi guys, and thanks for joining in. In today's video, I'm gonna explain to you what do we mean by transfer learning in AI, and how is it in comparing with traditional machine learning, and what's like the use cases. How can we use the transfer learning into creating or designing models for new tasks. Okay, so let's go ahead and define what do we mean by transfer learning. All right, so a simple definition of transfer learning in AI is simply we take a training instead of from the beginning, instead of training a deep neural network from scratch, okay, we take an already pre-trained model or network, and we use it as a starting point for us, or we adapt it to design or to train our new network. What do we mean by that? Let's take a look at the illustration over here. Okay, let's say we have a huge data set, and it's labeled, it's available, it's free, and it's existing, and there is a model that was trained on this data set. Okay, and we have the output for this task. Let's call this task A. Let's assume, for example, task A is a classifier to identify the different breeds of dogs. Okay, so our type of data is images. Okay, so it's an image classifier, and we are training on different images, okay, of dogs from different breeds, and the classifier would identify for me which breed this dog is. Okay, and let's say the size of this data set is 100K, huge data set, and it's all labeled and it's clean and available. All right, our model, the model that was trained on task A, the dogs breeds classifier, would perform very well, and we would get high accuracy, and let's say 97 or 98% of accuracy. Now this task is done. I already have a good classifier on it with high accuracy, and the data is available and everything is good. Now let's shift now. If we have a different task, let's say we want to identify the rare type of skin disease. We have a very rare skin disease, and based on the images of this disease, skin images, we wanna design a classifier that would identify for me whether if this is the disease of interest or not. Okay, but let's say we only have 200 or 300 images of this disease. How would we design a network or a model without overfitting, or without with this very small amount of data set? Okay, we would use the pre-trained model from the dogs breeds classifier, the knowledge that we got from that model, and we would use it to adapt it to solving task B, which is identifying the rare skin disease. Okay, so we would transfer the knowledge that we learned from task A model or network into our new task model that we wanna solve, or we wanna that's of interest for us. Okay, this way we didn't start from scratch. we use task A. We use task A model as a starting point for us, and we adapted it to our target model. All right. So in simple, we are taking already pre-trained neural networks as a starting point, like pre-trained on another task as a starting point to train or to create a new model for a different task. Okay? And like now you are thinking like how is this different from machine learning, and like how is it in comparison with machine learning? All right, let's take a look at this illustration. In traditional machine learning, we would have the scenario is like usually we would have a business problem. We would design we would frame it as an ML problem or a neural network problem. We would take our data, pre-process it, prepare it. We would use this data to design or train a model that would solve task 1. All right. Now, if I have task 2, I would have to create data separately for task 2, train it, and use that data to train a new different model, like separately, to solve task 2. All right. So there is no any crossing happening here. We have task A of identifying task 1, of identifying different breeds of dogs. Task 2 will be identifying the skin disease. This dataset would be like 100K or 200K, and this dataset would be 200 rows. Okay. Now, in transfer learning, we are learning new tasks. So we are solving new tasks based on previously learned tasks. And in this way, the learning process can be faster, more accurate, and we would solve the shortage of data problem that we might have. So how would we do that? Let's say our task here is the dogs. Like this data is for the dogs breeds, the images, and we are designing the classifier for this dog for this data set. We're done. We trained that model. This model is performing very well. We would take the knowledge that we learned from that model, and we would use it and adapt it to learn and solve the problem for the new task in parallel with taking the new data set, a small portion of the data set that is relevant to task 2 only. Okay, so what do I mean by knowledge? Knowledge could be the weights of the features, could be the most important weights in the most important features in the model. Could be the number of iteration or epochs that the model would go over. That's what we mean by knowledge. The layers, the order of the layers, the activation functions. What do we use as the okay, yeah, forget it. Okay, so that's what we mean by knowledge. Now, let's take now you might be thinking how I get the idea of transfer learning, but how would I use it? Okay, so basically we can just simply use transfer learning into these scenarios, these possible scenarios. Of course, there might be different scenarios, but these are the ones that are most commonly used. Okay, first, as a classifier. So the pre-trained model is directly used to classify the new classes for the new task. Okay, now what do I mean by as a classifier? remember the dogs task for identifying the different breeds. Imagine that I would have this neural network that I designed for it, and at the very last thing is the layer that would generate for me the output, like the different breeds. Okay, instead of this layer, I would take it off, replace it with a new layer to identify whether this is the real disease the skin rare disease that we of interest or not. Okay, we can also use transfer learning as a standalone feature extractor, like in the scenario of standalone feature extractor. Basically, we would use the pre-trained model to extract the relevant features only for the new task of interest. Okay, because that model is performing well, like it's already doing well, and we know the good features, the type of features that are possible. So we take them and we mimic that as an integrated feature extractor by plugging in and integrating the pre-trained model into the new task model. What do I mean by plugging in? It means that I take the whole model layers and I fit it into my new neural network design. So I take it as is and I put it into my neural network design. We refer to this as frozen layers. So we already know that these layers do well, okay, on these features and are well trained and well fine-tuned. We just take them and put them into the new design for the new task. For weights initialization, so in the weight initialization, we both plug in the pre-trained model and at the same time train the layers of the pre-trained model. So we are doing retraining here with the new task model layers. So we know what are the good weights for the features, and we retrain it on the new data set, and we fit it with the new task model. So in simple, we use it for weight initialization, meaning we integrate and plug in the pre-trained model, and at the same time we train the layers of the pre-trained model, not the new model, the pre-trained model, okay, to along with the new task model. Okay, this is it for today, guys. I hope I managed to transfer the idea of transfer learning to you, and I must say this is a very abstract explanation of what transfer learning is and how it is in comparison to traditional machine learning. Of course, there is a lot of math and statistics involved, and there is a lot of neural networks concepts that you need to go over to fully understand how to use transfer learning and how to successfully plug it in or design design models using it. All right. If you like this video, please feel free to subscribe and see next videos and give it a thumbs up. Also, I would love to hear from you if there is anything in particular that you want me to cover. And this is it for today. Thank you, and thanks for tuning in. Bye.